Hey everyone, I'm Alex from OpenFord. In this video, I want to share with you a full guide that will be split into multiple videos since the topic is very large and technical. I will break down layer by layer the upcoming EIP-8141. We will talk about present problems and the architecture and the real example of the EIP. So this is the first video of the full overview of the EIP 8141. So let's start. So basically today every Ethereum account uses the same type of lock, ECDSA. So basically every single one accounts all depending on the same cryptography assumption that elliptic curves discrete log is hard, and the ECDSA is baked so deep into the Ethereum transaction model that even our best account abstraction solution can fully escape from that. So let's take a quick look on the historical timeline of the account abstraction. So basically in 2020 it was the first proposition of the EIP-2938 that it's failed. Then it was the proposition of the ERC-4337. So basically today it's functional layer for the account abstraction, but it's application layer, not inside the protocol. And then we got after Pectra upgrade in 2025, the EIP-7702, based on the protocol that we can basically attach any code to our EOA. And the future upgrade, we will expect the EIP-8141, the frame transaction that I'm going to break down in this video. Let's focus a little bit on the ERC-4337 that lets to your smart account use any type of signature scheme, but the bundler that submits the user operation, that's still an EOA, still the same ECDSA. So the chain of trust always bottom out of the same curve. So what if we could remove the ECDSA from the critical path entirely? So what if Ethereum transaction model was redesigned from the scratch from the account abstraction? But still we can see in this diagram that basically even with the current upgrade of the EIP-7702, we can attach any logic code that basically can verify and validate the signer inside the smart contract. But in all this chain, we see that the bundler who submit that the user operation was signed by any signer, and it's basically submitted with the EOA. That is what EIP 8141 proposes, a new type of transaction. It's a type 0x06 called a frame transaction. It was basically authored by Vitalik Buterin, Light Klein, Felix Lang, Yoav Weiss, Alex Frosha, Dor Tirosh, and Shahar Naxon. Part of that, it's the guys basically who design the ERC-4337. So it was present as a headliner candidate for the Hegota upgrade, basically the second next upgrade that will be in somewhere H2 of this year. Okay, so let's talk about some problems with the current system. There is some structural problems that baked into the Ethereum current transaction model. For my opinion, one of the main problems is the ECDSA monoculture. So basically every transaction on the Ethereum today is authenticated by recovering of the curve SEC 256K1, the public key from an ECDSA signature. There is no mechanism at the protocol level to use anything else. Basically, you can use with any other signers, like for example P256 or WebO10. So if you want a different signature algorithm, you have to build an entire application layer abstraction on the top. So we can see the ERC-4337 basically providing this to us. And even then, you can still fully not avoid the ECDSA. So someone still need to submit the transaction to the chain. So basically the bundler, the EOA. I think this is a single point of failure. Also, the post-quantum cryptography is very advanced, but Ethereum has no native way for individual accounts to adopt them. So if we want to add post-quantum as a new protocol level signature type, so we would be guessing, for example, which scheme will survive or its quantum resistance. And if that scheme gets broken, so every time we will need another hard fork. The second problem, it's like a semi-problem. It's focused about the gas payment and gas sponsoring. The sender of the transaction must pay for the gas. There is no protocol level mechanism for someone else to pay on behalf of you. This means that onboarding new users require them already to have in their accounts any native token. So it's kind of chicken and egg problem that has splashed in Ethereum UX for years. So you want to use any DApp. So first go to exchange, buy some ETH, withdraw to your wallet, and then you can do anything. That's basically something that's very bad UX. But we have the ERC-4337 that basically solved this issue. And the issue basically solved with the paymasters, but it's the application layer. The gas is still initialized and front by the bundler EOA. So basically the bundler still need to pay with his EOA the initiate gas to relay the user operation to the entry point. Then of course refunded through the contract of the entry point. So this works, but it adds more gas overhead per user operation. So just imagine every time that we are executing user operation, it's doing a lot of logic and different internal and external calls that basically charge you gas. So this is introduced bundler's dependency also and creates a censorship surface. So the bundler decides what to include, for example, or what not to include. And the last problem, it's also kind of semi-problem, because after the upgrade of Backtrace, kind of we got this solution of the smart contract basically can initialize transactions, but if we not upgrading our accounts, so still smart accounts can't initialize transactions. So the only EOAs can send transaction on the Ethereum. So if your account is a smart contract, whether it's like, for example, multisig or social recovery wallet or anything more than sophisticated than raw private key, you still need another account, an EOA, to trigger any transaction on this smart account. So smart contract wallet, they're like second-class citizen in the Ethereum transaction model. So they can receive calls, but they can originate them. So of course, the current account abstraction layer with the ERC-4337 uses bundler as that basically trigger, and we have the EIP-7702. Let's do the EOAs delegate any code, but the transaction still start with the ECDSA signature. And also there was like EIP-8074 that basically tried to propose new opcodes, auth and auth calls, but it was, I think, superseded. So every approach to date has been constrained by the same fundamental assumption that the transaction been with SEP 256K1 signature recovery. So here the EIP EIP-8141 that basically aims to solve these problems that I mentioned, maybe more, in one proposal. So by introducing a new type transaction where the validation, verification, gas payment, and the execution phases are all expressed as programmable steps inside the transaction itself. So let's take a quick look on the actual transaction format of the EIP-8141. It's a frame transaction basically, but with a type transaction of type 6. So notice what's the different immediate in the transaction format. You can see there is no field from or field to or value. So basically this is the main fields that we will have inside the transaction. So there is a sender field that basically described who is the sender. In a legacy transaction, the sender is basically recovered the ECDSA signature, that it's the entire authentication mechanism right now. Here the sender is basically declared upfront, and authentication happened through the code execution inside the frame. So this is the key of the architecture shift, I think. So as you notice, there is no value field, no to field, no access list or authorization list that we have in the EIP-7702. So this is deliberate minimalism. So ETH transfer happened through the account own code, that basically we are doing a low level call that basically transfer the ETH directly to any other account. So it gives to accounts full control over the transfer logic, then spending limit, whitelisting, multi-party approvals, whatever basically we can implement inside the code. And the EIP-772 authorization list is omitted because it relies on the ECDSA in the end. So exactly what we are trying to move away from. So here you can see basically how the frame will look like. So the frame have like RLP tuple with 4 fields. It's the mode, target, and gas limit and data. So this is what we will transfer in the frame to the account inside the transaction type 6. This was a very high level and quick overview of the EIP-8141. In the next video, we will deep dive more for the technical details of the EIP, and we will see different architecture design, and basically we will see how the frames from the inside they are working. So see you in the next video. Bye bye.